Hello. So I'm just going to look at some of the directed study activities. In this case, we're going to look at the two-way MANOVA practice activity that was set as directed study, so if you wanted to do it. So the first thing we need to do is look at what kind of MANOVA we're going to want to run. So in this case, we need to run a 2x2 between groups MANOVA. Need to think about whether that's appropriate or not. Look at some of the assumptions, and then think about how we can interpret our output. Okay, so I've got the data file open already here, so we can have a look at it. So we can see we have a column for ID, so that's a unique number each individual has been provided with in the study. And that's useful. It helps us sort our data set back in the original order, and this can be a very useful thing. If you know the order in which people have taken part in, you can check things like the way that error in the model correlates if you're doing regressions and things like that. The next column over we have smoker, so whether someone is currently a smoker or a non-smoker. And the next column after that is gender, which is classified here as male and female. And then we have two well-being variables as our outcome variables. So mental health and physical health. So because you're either a smoker or a non-smoker, you're either male or you're female, this would make sense that it's a 2x2. So 2 IVs with 2 levels each. Between groups, because you're either a smoker male, smoker female, non-smoker male, or non-smoker female, so you appear only in one of the cells in the design. So between groups, again, that makes sense. They're all independent groups. And we've got 2 DVs. So this makes sense that doing a 2x2 MANOVA in terms of the research design. What we need to do is check whether it actually makes sense in terms of the data that we've got. So we'll have a look. So the first thing to do is we need to split our file. This is because we're going to start looking at our data in terms of if it's normally distributed or not. So in order to do that effectively, the first thing we should do is carry over one of our IVs and split the file by that IV. So this splits our output file. So all our output, until we turn this option off, will be organised into output for smokers and output for non-smokers. And you'll see why we need that in a moment. So we click OK. What will happen is the output file will appear. And what we can see, this is a log. Now it's always useful to keep an eye on this log. We can see the file we're using. We can see the data set that we have and what we've asked it to do. Okay. So if you go back to the data file for now, what we need to do is check the distribution of our data. When you have more and more complex designs, it becomes harder and harder to check things like normal distribution, but we'll sort of eyeball it to start with and look at what's going on, and we'll use our descriptive statistics in order to do that and some tests of normality. So we go to Analyze, Descriptive Statistics, and Explore. Now we know we've already split our output file up by smoking status, so what we want to do here is split it up by gender now. So we're going to ask for all of our data to be separated out by gender as well. So we transfer gender into the factor list. We transfer over our 2 dependent variables. These are the variables that we want to explore the distribution of. We transfer those into the dependent list. Next, we'll just go through and check our options. Let's just check on statistics. So click on the statistics button. So descriptive statistics are going to be produced. That looks fine. And we leave the default options as they are for that. The next one we want to check is called plots. So if you click on the plots button, we want to ask for our histograms to be produced. We also want to ask for normality plots with tests to be produced. So make sure those 2 options are ticked. Click continue. And then we'll just check options. Now in this case I'm going to leave the default option to exclude cases listwise, because that's what's going to happen if we run the MANOVA. So we want to look at the data as it's would be for our MANOVA, in which case we need to leave it as listwise. In this data set I don't think there is any missing data anyway, so it wouldn't cause a problem, but these are the options you'd need to check in order to decide whether listwise, excluding a case if it has missing data on any variables, or pairwise, excluding a case only on the variable where it's used in an analysis, is more appropriate. So in this case we'll leave it as the default, click continue, click OK, and SPSS will examine. You can see here, so it's doing something, it's processing, and here we go. Now the first thing we can see is it split our our output file up by smoking status, because we asked it to do that. So the first part of the output is going to focus on the smoker participants, so participants who are grouped into the smoker condition or the smoking group. We have some information on gender here. We can see split up that we have 10 males and 10 females for data on mental health, and 10 males and 10 females for physical health. So it's the same 10 males and the same 10 females. The next table is the descriptives. What we're really looking for in these sorts of things are the mean. So we can see they scored a mean of 61 points. Females, their mean slightly higher, so they scored a mean of 63 points. But what we're really interested in is looking more at the moment of the normality of the data. So one thing to check is the mean for each of these subgroups, the mean compared to something called the trim mean. The trim mean is where the tails of a distribution are cut off. So if you have a very extreme variable, that would sit in the tails of the distribution. If you trim it off, what would happen is that there would be quite a large difference between the mean and the trimmed mean. There's no hard cutoff as to what that large difference would look like, but in this case we can see there's hardly any difference at all when we cut off our extreme values. Our tails are trimmed off in comparison to the original mean. So for this group, it would suggest for the smoker male group, there probably aren't many extreme outliers. We check the minimum and maximum values, make sure they make sense in terms of what we know the range of potential values could be. And the next thing we want to look at something called the skew and kurtosis value. So the skew value tells us whether the bulk of our data will be to the left and the right of the graph, and whether the tail of our distribution will be to the left or the right of the graph. If there's absolutely no skew, so if it's a perfectly bell-shaped curve in terms of where the tails are equally spread out over the left and the right hand side of the graph, what you'll see is there would be a value in the statistic column of 0. As a rough rule of thumb, we usually say that values within plus or minus 1 are usually okay, but that's not always the case. But in this case, that looks okay. It's just over 1, so that's probably nothing too concerning. Kurtosis is how pointy the distribution is. So again, if it was perfectly bell-shaped curve, then gradually sloping sides, what we'd see is a value of 0 there. A positive value suggests that we have a more pointed distribution than normal. A negative value suggests we have a flatter distribution than normal. Likewise, skew, negative value means you have negative skew, so the tail of the distribution is to the lower end of the scale. Positive values mean you have positive skew, the tail is to the higher end of the scale. So in this case, again, that's just over 1, so it's probably nothing too concerning at the moment. So we would do this now for every single subgroup we have on both our variables. So for the moment, we've only looked at the smoker groups for males and females, and for the mental health variable, we need to do that for all of them. So we'd scroll through. So I'm going to leave you to look at that and see what you think. The next thing we check is our test of normality. Now, if you have very large groups, if you have large groups, so over 50, you can really use either of these tests. If you have very large groups, they tend to be very, very sensitive. So they tend to return a significant result purely because of the size of the sample. And what that means is if you find here in the column a value of 0.05 or less, then it would be a statistically significant result. If it's statistically significant, it is significantly different from normal. Your distribution would be different from normal. You would have violated the assumption of normality. Your data would not be normal. As I said though, if you've got large samples, then it'll tend to return a significant result regardless. And what you'll need to do is to check all of the rest of the descriptive statistics and your histograms to make a decision on balance. In this case, we've got a small sample. So when you have small samples of fewer than 50 cases, you should really use the Shapiro-Wilk test. It's slightly more robust. What we can see here for the smoker group, on the mental health scores for male and female, we can see that all of these values are greater than 0.05. So what you found is your data is not significantly different from normal. You have not violated the assumption of normality. So this is all kind of coming together quite well. That's reassuring. But we want to check our distribution looking at our histograms. Now, one of the issues is with only 10 cases, this is a small sample, it'll be very hard to eyeball your histograms. I mean, in this, it's nothing too concerning. The rest of the information suggests that there isn't too much going on. I mean, this does not look particularly normal. But as I said, this is probably due to the fact that you have quite a small number of cases. Now, if you're at all concerned at this point, what you could do is potentially collect more data, but that might not be something that's feasible. So if you can't collect more data, you'll need to make the decision whether on balance all of the information suggests that there are problems or not. If you feel that it's safe to proceed, we can go on and do the MANOVA. If you don't feel it's safe to proceed, the issue is that you'll need to probably break the analysis down, as there's no non-parametric equivalent to a MANOVA. Okay, but in this case, I'm going to say that on balance, the information suggests that it looks okay, but it might be a caveat. So we'd scroll down. The other thing we want to look at are our box and whisker plots here. So this is the median value, the interquartile range, and what we'd like to see, if we had very normally distributed data, you'd have the median in the middle of the box, and the tails would be equally distant from each other. One thing we also want to double check is, are there any asterisks or circles which appear outside of these whiskers? So these box plots, SPSS identifies if there are outliers that don't fit, that are extreme values in comparison to everything else. I believe that a circle is usually 2 standard deviations away, and asterisk, if you see it, is 3 standard deviations away. So usually a circle, it's something probably to look into a little bit more detail, but it may not be that concerning. An asterisk, it's usually more concerning, so it may be that you need to check that the data has been entered correctly, and so on. One thing you want to try and avoid is having outliers, because a lot of the tests don't run well with them. So you'd need to go through the rest of this output. So if I show you what it looks like on the left, you would go through every single one of these and decide whether on balance the information suggests that the data is normally distributed or roughly normally distributed or not. If you had outliers, you need to consider what you would do with them. So you can see here that the first part was in relation to the smoker group, broken down by males and females. The second part of the output is the non-smoker group, broken down by males and females. So we just have a very quick scan through to see the rest. Again, we'll be looking at our means, trimmed means, our skew and kurtosis values. All our Shapiro-Wilk tests there are non-significant, which is promising. these look fairly normally distributed and so on. So you would do that, but you'd spend more time and do that in greater detail. The next thing we need to do before we go any further is to look at we need to look at all of our output together again. So we need to go back to split file and ask for SPSS to stop organising our output by groups and instead analyse all the cases as one. So we click Analyse all cases, do not create groups, and then click OK. And at the end of the output, you'll see split file has been turned off. So the next thing you want to do is actually have a go at running the MANOVA. So if we go back to our data set, looking at how this is set out, okay, we need to go to Analyse. We need to go to General Linear Model and Multivariate. Okay, so our two IVs are smoking status and gender, so we would transfer that to the fixed factor group here. The next, we want to transfer over our two DVs, which are mental health scores and physical health scores, and they go into the dependent variable box. So we can ignore the model and contrast button, we can leave those as the defaults. The plots, we want to potentially separate them out for, it might be good to have, you can play around with this so that you get it to display it as you want to. But we'll have separate lines for gender and we'll have our horizontal axis broken down by smoking status. We'll add that and then continue. We go to post hoc tests. Now actually we don't need post hoc tests in this case because our smoker and gender variables have only got two IVs. So if we find a difference between them, we know it can only be between those two groups, so smoker versus non-smoker, male versus female. So in this case we don't actually need post hoc tests, so we'll click continue. We'll go to the save option. Now we probably want to save the Cook's distance. There are other things you can save in terms of checking your residuals to see if you've got any really extreme errors in the model. But we're going to focus more on, for the moment, the Cook's distance. We'll click continue. So Cook's distance will help us identify if we have a multivariate outlier in there or more. And then we'll go to options. And what we want to do is transfer all of these over, so we've got some descriptive statistics for each of these things. Now, because we know we have only two groups for smoker, two groups for gender, we don't need to compare the main effects in this instance. What we'll do is we'll run the analysis first, and we'll explore whether there is an interaction between smoking status and gender on the variables before we decide to investigate that further. Okay, but in this case we don't need to compare the main effects because we know we've only got two groups for these two IVs. The other variables we want to choose are the descriptive statistics. Other statistics we want to choose would be the descriptive statistics, the estimates of effect size, and the marginality test. So these are sort of the core ones, but there are others you can choose. We'll just stick with these for now. And we'll click continue. Then we'll click OK. And what we can see here is we've got smoking status broken down, how it's been coded, gender, how it's been coded, and the number of cases that we have for each of those variables. The next table we've got the descriptive statistics. So broken down first by the DV, so in this case mental health score first, then broken down by smoking status and then by gender. So we can start to eyeball whether there appear to be differences. And we'll need to report that information later on, but in this case we'll just eyeball it. Next thing we want to do is check some of our assumption checking. So the boxes test for quality of covariance matrices. This value needs to be greater than 0.001. And in fact, this tends to be extremely sensitive. So as long as you've got equal groups, you can be fairly safe to ignore this test result if it's statistically significant. Where there's a problem is whether if this is statistically significant and you have unequal groups, that's where you can start to have a problem, and you'd need to do further investigation into why that result was statistically significant. There's a good chapter, I believe, on that in the Tabachnik and Fiddle Using Multivariate Statistics book, which is available as an ebook through the library. We'll quickly just scroll down to the second assumption check here, which is Levene's test of equality of error variances. What we want is a non-significant result, so we can see that both of these are greater than 0.05, so we can be fairly safe in concluding that we haven't violated this assumption. So these are all good signs. Okay, so now we'll start to interpret the results of the MANOVA. So we have smoker status here. Now you have 4 different types of statistic you can choose from. You need to report only one. When you have unbalanced groups, so you have more smokers than non-smokers or so on, then MPSY trace tends to be the more robust measure to use. As a default, most people will interpret Wilks lambda. When you have only 2 levels of one IV, some people use Herteling's trace. One of the ones that most people argue to avoid is looking at the Roy's largest root statistic. So in this case, it doesn't matter too much which one we use. We've got balanced groups, but I'll stick with MPSY's trace. And what I'm interested in is the significance value. So here we can see that is greater than 0.05, so that's not statistically significant. And we do the same for gender. We carry across, we can see that that is greater than 0.05, so it's not statistically significant for gender. And if we look at our interaction, that's greater than 0.05, so that's not statistically significant either. So if these were our test results, we would report everything up to this point. We would say there isn't a difference. There's no main effect for smoking status, there's no main effect for gender, and there's no interaction between the two on the DVs when considered together. So we would stop the analysis at that point, and that's because of family-wise error. So if we proceeded, even though we've got this non-significant result, if we started looking at the rest of the output, we would be drastically increasing the risk of committing a type 1 error, which is making a false positive, purely because we're looking at the number of analyses we are. So this is a way of managing that risk, is to say at this point there's not really anything going on at the highest level, so we won't look any further. If the results were statistically significant, what we would do is we'd proceed through and we would look at tests of between subjects effects. So this breaks it down not just by our main effect, smoking status, gender, and then the interaction. It breaks it down then looking at the IVs separately. So we would interpret these. As I said, we can't do that in this situation because they're not statistically significant. If we went any further, we could break it down looking at males and females in terms of looking at our descriptive statistics again. And if we had found an interaction effect, what we could do is run that syntax that we looked at during the session to produce some tests of simple main effects. So breaking each level of our IV down by one other level of the second IV and looking at. So if we had found a statistically significant interaction effect, what we could do is run the syntax that we looked at during the previous session and look at simple main effects. So that's where you're looking at the difference between, in this case, 2 levels of, say, the difference between smokers and non-smokers on one level of gender. So male smokers and non-smokers, and female smokers and non-smokers, and so on. In this case, as I said, we don't need to do that because nothing is statistically significant higher up. Although there is something interesting going on here, looking at the plot, but this is obviously not strong enough to have produced any results, statistically significant results, higher up the chain, as it were. Okay, so if we look back at our questions now, so do you think 2x2 between groups MANOVA was most appropriate? Well, in terms of the research design, it made sense as we looked at, but there may be some issues in terms of the data, but possibly not substantial enough to prevent us from running the MANOVA. So the first question, we'd really be relating that back to the research design. Second question, we'd be looking at does it satisfy all the assumptions? So we would look at consider our the distribution of the data, if there are any outliers. If there were concerns, are they substantial enough to not run the MANOVA? Did we identify any assumptions of the violations? Well, actually, we checked a range of them. There didn't seem to be, in terms of Box's test of quality of covariance matrices, and there didn't seem to be an issue with the Levine's test. So in this case we don't need to resolve them, but we would probably consider some of the issues around sample size and potentially some deviation from normality in the data. So what we could also do is look back at our data set at the Cook's distance that we asked to be produced and check again, could there be any multivariate outliers producing an undue influence on the output. What we'd be looking for are values of 1 or greater, and there don't appear to be any, so again that's a good sign. Then we look at interpreting the data. So we've looked at the assumption checking, but what do the preliminary results suggest? So the main effect, there didn't appear to be any, and interaction effect, there didn't appear to be any. So we would only report that highest level result in this case. In terms of the scenario, it would all relate back to perhaps our hypothesis. So there doesn't appear to be an impact of smoking status or gender or an interaction of either of those things on health or well-being scores in terms of physical and mental health. So if we were looking at trying to improve those, that's an area that perhaps might not be that fruitful. So I would point out this is a fictional data set and a fictional study, but in this case it may be considering, well, how could we move that research forward? And so that's sort of one way of looking at this activity, and hopefully that's been useful.